reasonable to propose actually making or extracting the water on Mars for the mission. And in fact, at my company, Pioneer Astronautics, we built a simple device, and we took Mars simulant soil, desiccated to 5% water by weight, which is what Odyssey has found in many regions of Mars, and devised a system for extracting that water, and it's quite efficient. It's not particularly difficult. So at this point, I would consider not bringing the hydrogen to Mars, but in fact extracting the water. Also, from an engineering point of view, the only thing that's really new is the prospect of, in the reasonably near future, of having a 50-ton to LEO semi-heavy launch vehicle. That the SpaceX is claiming that they're going to have a Falcon Heavy available within a year of first test flight. So now, while that is not my ideal of a heavy lift launch vehicle, it's very much on the light end of a heavy lift launch vehicle, there's a prospect of actually having it. And so I developed an alternative design of Mars Direct. It's a semi-direct plan that involves 3 launches and a smaller crew, 2 people or perhaps 3 if you use small people. And there's something to be said for small people. No, there really is. We go for small everything else on space missions, and somehow there's this bigotry against small people, even though they're obviously superior. Wandering
off topic.
Oh yeah, off topic. Yes, I'm off topic. Anyway, so that I developed a plan to do. You could do a semi-direct mission, a 3-launch mission using a Falcon Heavy. Those are the 2 differences. Let's have a question for Jim Bell. Let's alternate it. Sir?
Yes. I noticed that there were some caves reported on Mars. Maybe this is important, some shielding for people for radiation. Where are these caves, and how many of them are there?
Yeah, so the questions about
near water.
the questions about discovery of caves, and these are likely lava tubes. They occur around some of the younger volcanic areas of Mars near the equator and Tharsis area and Amazonas, other places like that. They are unfortunately nowhere near anything interesting mineralogically or geochemically, other than the volcanoes themselves, which are interesting to some people. But they do they would provide meters of rock shielding. Of course, all we know is there's a hole there, and it's assumed that there's a lava tube, so that you could probably go laterally once you get inside that hole. We don't have the technology at present to send a robotic probe into them or land with that accuracy that would be required to get in, land inside of them. I don't think we have the technology yet to have some kind of a robotic probe that would rappel down in them, and we don't know enough about them yet. But so they're hanging out there as a tentative place that you might want to think about for a naturally shielded environment.
There's no shielding in any feasible depth below the Mars surface against the radiation. So electrons rays on this Earth, those radiations go right to the center of the Earth, and they will do the same in Mars. So don't talk about radiation shielding; it doesn't work.
Well, people actually do survive on the surface of the Earth, even though. Okay, well, a question for me, sir.
Robert, if Mitt Romney gets elected, what are we looking at?
As far as Mars goes.
I don't know. This is an unfortunate situation, which is why I'm voting for Washington and Adams this year. But this last fully qualified ticket. But Romney, of course, made some rather negative statements about space in response to Newt Gingrich, who had come out with a visionary program, although not well presented, and it was opportune for Romney to mock him with respect to the Florida primary. Now, the question of how important that is to Romney, or will they get out the Etch-a-Sketch? Hopefully they will. Romney's advisor on space is Mike Griffin. Okay, so it's possible that they might have at least reasonable support for the space program as it was conventionally conceived and supported along the lines of Griffin's ideas. I don't see Romney, however, announcing a visionary space program unless he's impelled to do so from outside events. And that's another thing. You can never tell. There's all kinds of contingent events that occur. Kennedy was not announcing a visionary space program when he ran for president, and yet he did in response to outside stimuli. And I can't say. So I think what's the more useful thing is what can we do to try to have an outcome be favorable should Romney win, and the answer is that to speak to people that in some way network into that camp and say, look, this country was built by a nation of pioneers, and it was built by people who insisted upon being the vanguard of human progress, and that's what you have to do. And in particular, at this time when the United States is being passed by China in numerous fields, and we're not responding to it in the way we responded to Sputnik, which is, saying, hey, we're not putting up with this, let's get on this ball here, to accept a declining space program is to accept national decline. And that is something that this country cannot afford, and to try to make it clear to them. So I think, Romney, it has been widely remarked, is a sort of political chameleon. Well, maybe we could get him to change to more favorable colors. Question for Jim Bell.
Yes.
Given that Mars is a desert environment, has desert varnish been considered as a possible source of the clay signature?
Yes. The problem with so the question is about desert varnish, and yes, that is on the list of things to look for, and there are varnish coatings on many of the rocks that we've seen at both landing sites. Part of the problem is that geologists on the Earth do not fully understand desert varnish and the role of biology and different kinds of microorganisms or macroorganisms in forming those coatings on rocks. So, but absolutely, that's one of the things that's in the mix.
Okay, one for me. Sir.
Yeah, I wanted to address a little more the question that was raised from the audience. How does Mars compare to Earth in the area of survivability related to radiation, cosmic radiation? I know Mars has a very thin atmosphere. So do we need to be in a cave when we're eventually on Mars? Do we need to be living only in caves, or how?
No, I don't think so. Let me explain. The Martian atmosphere, as thin as it is, if you go from the surface straight up to the zenith, there's 16 grams per square centimeter of mass, okay, which is like 7 inches of water, and which is more than you'd have in a solar flare shelter. Furthermore, if you average the mass between you and space over the 2 pi steradians of the sky, because most things are not going to come straight down, they're going to come in from a slant, it works out to 65 grams per square centimeter, which is like 2 feet of water. Yes, and and that's a lot more than a solar flare shelter. So in fact, on the surface of Mars, at all times, you're actually in a fairly good solar flare shelter. And it is, I'm sorry, but it is true. And please don't interrupt. I'm talking about, okay, thank you. Please, sir, that's cosmic ray, that's solar flares. And as far as cosmic rays are concerned, you will not be shielded effectively by the Martian atmosphere, which we on the surface of the Earth are shielded, okay? We are shielded on the surface of the Earth by the equivalent of 10 meters of water of mass above us. That is what actually shields us from cosmic rays, not the Earth's magnetic field. And
hey, I didn't pay for your opinion, I paid for theirs.
okay, all right. And Anyway, so you will get a cosmic ray dose on the surface, but I have to say that it depends how long you want to stay. If you're staying for the length of a Mars mission, you'll take a certain dose from galactic cosmic rays on the surface. It'll be somewhat less than half of what you get in free space, because Mars, of course, will block out half of the sky beneath you. And you could put sandbags on the roof of the HAB. That would reduce the dose somewhat, but you'll still get some cosmic ray dose. But overall, you're talking about a round-trip mission dose on the order of 60 or 80 rems, which is order of a 1% risk of getting a fatal cancer at some point later in your life, assuming no advance in medical technique. Now, if you stayed there longer, if you were a settler, that dose would increase to something much more material. And so for Mars settlements, we might well want to consider underground vaults or much more substantial shielding. But for Mars exploration missions, the radiation dose is actually a modest portion of total overall mission risk. Okay. One for Jim Bell.
Sure. How about, yeah.
Can you say something about possible future missions to find like vents or crevices for the emission of methane?
Sure. So, in fact, one of the unfortunate casualties of the cancellation of the cooperation with the Europeans was an orbiter in 2016, which would have had a very sensitive spectrometer that could detect localized enhancements of methane and many other trace gases. The technology exists to do that. And I'm convinced that on some future orbiter in the not too distant future we'll fly an instrument like that for that exact kind of mission. It has to have very high resolution to identify, specific localized areas of possible enhancements of any trace gases, and it has to have very sensitive spectrometer to it. So it's within our grasp to do it. We need an orbital platform, a low orbital platform like our Odyssey or MRO or whatever to do it. Maybe the Europeans and the Russians will do it together before we do it. That would be good for science. As an American, I'd like us to do it, but whatever. It'd be good for science. So I think a mission like that will come up. And it's also important to note, and Robert mentioned this, that Curiosity will make a measurement of methane in the atmosphere. And it's important to note that there is a huge controversy in the scientific community about whether those methane results that have been reported and published from ground-based telescopes are correct. If they are correct, it means that we have a dramatic misunderstanding of photochemistry. And maybe that's true. Or maybe Mr. Occam would say, well, those measurements aren't right. I don't know. But MSL will make this test just by sniffing in the atmosphere, and it will have a sensitivity of about 1 to 3 parts per billion, maybe higher, worse sensitivity early on and better sensitivity later when they understand the instrument better and its calibration. But if there is any methane in the Martian atmosphere, whether it's variable or not, if there's any, MSL will detect it. And it's one of the results that we could do relatively early in the mission. And so there's a lot of impetus on the science side to go ahead and make that measurement. So that'll be a first step, but then an orbiter platform to make detailed mapping is definitely possible and got to be an option for whatever NASA decides to do in 2018 or 2020.
One for me in the back. Sir.
A follow-up question. Will your instrument be able to tell the difference in the methane generation between potentially biological origins and serpentinization?
That's an excellent question, and the answer depends on who you talk to. There are isotopic differences between biogenic and abiogenic methane, but there are also isotopic differences between different kinds of abiogenic methane. Okay, and so a lot depends upon the details of the chemistry of how that methane is formed, what kind of, there's ways to form methane from the decomposition of olivine, which is a common component in the Martian subsurface. And under certain kinds of chemistries, you can get different kinds of isotopic ratios. So I do not think that will be a slam dunk, okay? I think that the team might be able to make the case that, we detected this signal of this certain kind of isotope or this certain kind of chirality or whatever, and therefore this is consistent with this being biologic. But I don't think that alone they would be able to cross the line and say this is evidence of life on Mars with these instruments. Now, that would be, you know, an extraordinary claim to make, which would, as we know, require extraordinary evidence. So.
Are there any minerals on? Can we rule out there being minerals on the Earth that there are not on Mars? Are there any minerals we can rule out that do not are not contained on Mars?
Sure. So minerals are just collections of elements, and the elements are the same. Periodic table is the same here on Mars and Andromeda Galaxy. It doesn't matter. So minerals are just combinations of those atoms into different kinds of molecules, and it's totally dependent upon the environment. So, for example, there are kinds of minerals that form in tropical rainforest soils on the Earth. And you're not going to find them on Mars, right? There's just no environment like that, and there probably never has been an environment like that. Okay, so whole classes of minerals you're not going to find. There's probably minerals in the Martian environment because it's been so dry for so long, and the chemistry is so sluggish, and it's been dominated by processes that are really slow and insignificant on the Earth, like, you know, sand grains hopping from point to point over 2 billion of years can do a lot of work. They don't get that much time on the Earth to do that kind of work. So there are probably minerals on Mars because of the unique environment that you don't find on the Earth as well.
Okay. Question for me? Red shirt.
In all the mission designs I've seen by NASA and others, they don't spin the spacecraft the way you do to, you know, prevent bone density loss and so on. What are the objections to spinning the spacecraft? Why are they so reluctant to take on a tethered spun spacecraft for artificial gravity?
It's interesting. Back in the 1980s, I was at a conference, and there was a NASA manager of the space station program, and I asked him, why aren't we building an artificial gravity space station? And he says, well, because when we go to Mars, it's going to be going in zero gravity. And I said, well, why are you going to Mars in zero gravity? He says, because all of our data is going to be on zero gravity. And no, it is a real problem. In Apollo, look, the space medicine community was created during the Apollo program, which is pretty much when NASA effectively was created. And the task there was to make sure people could function in zero gravity on brief trips to the moon and back, that they could eat, they could function, they could do things, that everything could be handled. And so the zero gravity community, the space medicine community was created around that issue. Artificial gravity was clearly not necessary for Apollo. And okay, so then afterwards, they were the people who had the ball. And anytime anybody in NASA tries to introduce the idea of studying artificial gravity, they get shot down. I mean, NASA has never flown a single artificial gravity spacecraft. We have not flown a single spinning spacecraft with a mouse in it. Okay, this is a space program. It's gone since 1958. The Soviets flew one such experiment, and it was in 1G. Okay, artificial gravity. But back in 1978 or so. But it is amazing. I mean, we had a situation every time, like some somewhat outlier space center like Ames. Okay, and we're going to have a speaker from Ames here very shortly, and he's sure an outlier. But but you know, they typically would propose something like this, and it would get to a certain level, and then it would be shot down out of headquarters. And it's a question of inertia. It's like if you read J. Baxter Finney's Scientists Against Time, which talks about the U.S. Military scientific effort during World War II, and dealing with the problem of hypoxia. And for the longest times, the doctors resisted putting oxygen masks in the planes. They wanted to find a pill that would solve hypoxia. They say, this is a medical problem. Get these mechanics out of this discussion. And eventually they were thrown out, and we implemented an engineering solution, because it's much easier to find an engineering solution to have people breathe oxygen from a mask than to evolve people to breathe less oxygen. And And similarly, it's a lot easier to rotate a spacecraft than to evolve people to adapt to zero gravity.
So, wait, young lady in the back there? Oh, young man in the back there, yes.
This little girl has been very persistent.
Astronauts do you send up to Mars persistently? Initially.
Was it how many astronauts would we send to Mars?
Initially.
Initially. The more astronauts you send, the bigger and more expensive the mission is going to be. So you have to keep it to a low number. My favorite number is 4, because it's the smallest number you can have in which you can divide the crew up into 2 groups and have no one be alone. And it allows you to be redundant on the 2 primary skill areas of the mission, which is field science and equipment repair. That is, the 2 most important people on the Mars mission, so to speak, are your field scientists, because they are the intellectual payload of the mission, and the flight mechanics, because they are the people who the life or death of the whole mission is going to depend on. And of course, you want flight mechanics who know a little bit about geology, and you want geologists who know something about equipment, but still, that's my favorite. NASA tends to design with a crew of 6, but it does make the mission more expensive. And if it's too expensive, it will never happen. So that's kind of the range. But if necessary, I would go with a crew of 2. All right, we're going to cut this off now, because we'll give our next speaker a bit more time than would otherwise have been possible. Okay. Okay. And do you have his presentation loaded in there? Okay. Our next speaker is going to be General Simon Pete Worden. I first met him when he was